हेलो वेलकम माय डियर स्टूडेंट्स, स्वागत है आप सभी का पीडब्ल्यू गल्फ में। आई एम वर्षा एंड आई एम गोइंग टू बी taking the summary of the chapter indefinite integration. Yes, a very important chapter from the board's perspective as well as mains. Boards में बच्चों definite and indefinite integration combined forms integration. And the weightage of integration chapter is around 10 marks in board examination. So out of 80, 10 marks is alone for the chapter integration. Integration, as I said, divided into two parts, indefinite and definite. तो आज हम indefinite integration के बारे में पढ़ेंगे. अगले summary session में आप इंतजार करिएगा. We will study definite integration definitely. Okay. What are the topics mainly in this chapter? Today we are going to revise what is integration, what are the ways of solving a question on integration, that is by substitution, by partial fractions, by parts. There are some special integrals also which we will be seeing, and it's important. That is where the students get stuck. Integration by substitution is the major part of the chapter. I would say 50% of the chapter is integration by substitution. Then remaining 20-30% is special integrals, and 5-10% by parts and partial. So that accompanies very small amount of the chapter overall, if I tell you. Well, before I begin with the actual chapter, let me give you a disclaimer that we won't be solving many questions. If you open your textbook of integration chapter, there will be more than 100 questions easily, and if you want I can give you at least 300 questions which I have in my question bank, but that's not the purpose. Today's purpose is revision of the theoretical part. Summary lecture, I will revise just the theoretical part of this chapter, what are the different types and how to solve those types. Okay? So it's going to be super fruitful session if you sit with your notebook and make notes. बच्चों क्वेश्चन सॉल्व करने से पहले इंटीग्रेशन में it is important that you understand it is coming from which type, what method should I use, how should I use that method. If you are clear with these 2-3 questions, solving an integral will not be difficult, and that is what I am going to do today. I'm not going to solve hundreds of questions. We can have a separate session for question solving of integration, but today we will understand each of the type, when to use substitution, how to use partial fractions, how to use by parts, how to remember them. I'll give my own tips and tricks for you to remember. So starting with the integration, are you all ready? Are you ready? Let's begin the session. So integration, integral f of x dx is equal to f of x plus c. This is your integral sign, integrand, variable of integration. After solving whatever answer you're getting, that's integral, and c is the constant of integration. These are the 5 parts of a complete integration. Whenever you write a question and an answer, these 5 parts should be there. Integration of function with respect to x. This d of x tells you you're integrating the function with respect to which variable. Like in derivative d by dx of sin x. That means you're differentiating with respect to x. d by dy of sin y. You're differentiating with respect to y. d by dt of cos theta. You're differentiating with respect to t. So similarly, you're integrating with respect to a variable, that is called variable of integration. Next, integration is nothing but just an inverse process of differentiation. If you know differentiation, उल्टा कर दो integration आ जाएगा, है ना? हाँ बेटा वही होता है. जैसे कि derivative of capital F of x is small f of x. So integral of small f of x will be capital F of x. Are you able to understand? Derivative is cut. Big function, this is capital means big, small means. So capital function, big function is differentiated to get a small function. Integral means all the smaller functions is combined to make a big function. All the smaller functions, small f, combined to make a big function. So like addition, subtraction, multiplication, division, differentiation and integration are opposite processes of each other. Remember that. Like derivative of sin x is cos x, integration of cos x will be sin x. Using this technique, we make a list of formulas which you all have to by heart. Before I go there, you must be wondering what is this C. है ना, बात करते हैं C के बारे में भी. Indefinite integral and constant of integration. चलिए, अच्छा वो वहां का यहाँ आ गया, कोई बात नहीं. So derivative of sin x is cos x. What is derivative of sin x plus 100? Cos x. What is derivative of sin x minus 9? Still cos x. So derivative of all these numbers is cos x. What will be integral of cos x? Will it be sin x? Will it be sin x plus 100? Will it be sin x minus 9? क्या करें, उल्टा होता है ना. तो बहुत सारी पॉसिबिलिटीज है. देयर आर सो मेनी ऑप्शंस अवेलेबल. So let's just combinedly call it as C, where C is nothing but constant of integration. Do we know what is the value of C? No, we don't know. It is just an arbitrary constant. It is just an arbitrary constant. Because we don't know the value of C, C can be any number. We are not defining where we are finding the integral. That is why it is called as indefinite integration. Why is it indefinite integration? Because we are not defining कहाँ से कहाँ तक integration करना नहीं पता. जैसे अगर if you know the limits, you are integrating a function from A to B. You are integrating a function within 2 points. Then that will be your definite integral. But what we are studying now is we are not keeping any boundaries. Let's be limitless. We are simply integrating the function. So while you are integrating, because it's indefinite, we don't know the boundary, in the answer you will get plus C. That plus C itself signifies it's indefinite integration. If there is no C, it will be definite. I will talk about the next slide, geometrical interpretation of indefinite integral here. ये slide थोड़ा सा swipe हो गया, कोई बात नहीं. What is the geometrical meaning of integration? Suppose I take a function y square is equal to x plus 3. Y square, okay, different values, yeah. Right. Yeah, y square is equal to x plus 3, x plus 2, y square is equal to x, y square is equal to x minus 1, y square is equal to x minus 3, and so on. ठीक है. What will the graph of y square equal to x look like? This y square equal to x. It's a parabolic curve, है ना. अभी ज़्यादा हम उसके इस पे नहीं जाएंगे. It's a parabolic curve. Suppose this is y square equal to x. So y square equal to x plus 2 will be somewhere here. Y square equal to x plus 3 will be here. Y square equal to x minus 1 here. X minus 3 here. And all you can see is only the shape remains same. The shape remains same. What is changing? Only the constant value is changing. Where it's intersecting the graph, only the constant is changing. So basically in integration, what we do, in integration, we calculate area under the curve. The geometrical meaning of integration is area under the. ये मैंने सही किया है क्या? y पॉजिटिव नेगेटिव, उल्टा लिखना चाहिए था ना बच्चों मेरे को. ये x स्क्वायर इक्वल टू ऐसा आना चाहिए. दिस इज नॉट ग्राफ. y स्क्वायर का ग्राफ तो राइट हैंडेड होगा. इट विल ऑल बी राइट हैंडेड. कोई बात नहीं, इसको थोड़ा सा स्विच कर देते हैं. कोई बात नहीं. y स्क्वायर इक्वल टू x ऊपर आना चाहिए. y स्क्वायर इक्वल टू x, फिर वैसे ही y स्क्वायर इक्वल टू x प्लस 2, x प्लस 3. तो ये जो भी कर्व के अंदर का एरिया होगा, दैट इज नथिंग बट योर इंटीग्रेशन. y पॉजिटिव नेगेटिव, x ऑलवेज पॉजिटिव. ग्रेट. So different curves, constant changes, the point changes, integration is area under the. Let's talk about some rules and formulas to solve the question. तो सबसे पहली property है, if there are two terms added inside an integration, you can separate the two terms. Integration of first term plus integration of second. ठीक है. Similarly, if there is a subtraction, यहाँ पे minus है, you can still separate and minus sign will be there in between. If you have a constant inside integration, just like derivative, you separate the constant out, put the constant outside and take the integration of remaining. So this is same like your derivative. Addition and subtraction, no problem. Multiplication and division, can we separate the integral? No. Here are a list of 18 formulas which you all have to remember. You can find it on Google, on my slide, in your textbook, everywhere you will find it. The way also is very easy to remember. You remember the formula of derivative, integration का automatic आ जाएगा. जैसे कि, okay, what is derivative of log x? 1 by x. So integral of 1 by x is derivative of e raised to x, e raised to x. So integral of e raised to x also e raised to x. e raised to x ना बड़ा ही खतरनाक फंक्शन है. इट्स अ फंक्शन जिसका ना डेरिवेटिव कुछ उखाड़ सकता है ना इंटीग्रेशन. Even the derivative is same, integration is same, both are same. So e raised to x is not affected by your derivative and integral. Integral a raised to x dx is a raised to x log a. In derivative, you would say derivative of a raised to x is a raised to x into log a. Divide. This is also an important formula, polynomial. Integral of x raised to n is x raised to n plus 1 upon n plus 1. In derivative, you multiplied, here you are dividing. In derivative, subtracted, here you are adding. And so on and so forth, guys. Just remember, trigonometric integral sin x is minus cos x. Integral cos x sin x, x square x tan x, cos x square x cot x, sec x tan x sec x, cos x minus cos x. Ulta of derivative. These are some inverse formulas which you again studied in derivative. Derivative of sin inverse x was 1 upon root 1 minus x square. यहाँ पे integral of this is, for sin and cos same thing with a minus sign. For tan and cot same thing with a difference of minus. For sec and cosec same thing with a difference of minus. ठीक है, पेयरिंग में चल रहा है. ये बाय हार्ट कर लो, रट लो, जिंदगी को आसान बना लो, वरना बड़े पंगे हो जाएंगे. Next problem, integration by inspection. So this is the first way of solving questions on integration. When we didn't know a lot of things, when we didn't know the formulas, तो हम क्या करते थे? हम guess करते थे. जैसे हमने guess किया, derivative of sin x cos x. So what will be integral of cos x? It will be sin. So that is your inspection method. Integral of x cube plus 1 upon x square will be what? If you separate them, you will get integration of x cube upon x square, which is x, plus 1 upon x dx. We just saw the property can be separated. Now you don't know the formula. Assume that you don't remember the formula. So you will try to think, derivative of what is x? Derivative of x square is 2x. Isn't it? Inspection bolte, ulta method. Derivative of x square is 2x. So derivative of 1 by 2 x square will be x. If derivative of 1 by 2 x square is x, so integral of x will be 1 by 2 x square. है ना भाई, इसका डेरिवेटिव अगर x है तो x का इंटीग्रल ये होगा 1 by 2 x square. And then also, what is derivative of 1 by x? Derivative of 1 by x is minus 1 by x square. So integral of 1 by x square will be minus 1 by x. Do you all agree? And आदत से मजबूर, indefinite integration plus c तो आएगा बॉस एंड में. So the answer to this question is x square by 2 minus 1 by x plus c. This approach is called as method of inspection, but it is a very boring approach. Now we have learnt a simple sada tarika. Integral of x raised to n is x raised to n plus 1 upon n plus 1. And same thing. This goes in the power minus 2 plus 1 will be x raised to minus 1 upon minus 1. Simplify. This did by the formula, this by inspection. Inspection method is old, traditional, forget about it. Now onwards only formula. Okay. So total there are 3 methods of solving a question on integration. You all should make this in your notebook. You will think, ma'am, हमको question solve करने से मतलब है, हमको method से क्या लेना देना? बेटा अगर तेरे को method नहीं आएगा, question भूल जा तू. अपने भूल जाके question कर पाएगा तू. ठीक है? तो जो टीचर्स बोल रहे हैं सुनो उसको अच्छे, करो तब होगा. Three methods: substitution, partial fraction, by parts. In substitution, you have LDSR, 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 LDSR. Let, differentiate, substitute, resubstitute. These four steps will solve your questions. Let, you will substitute something, then you will differentiate it, then substitute it in the question integral, and in the end resubstitute. LDSR, LDSR, LDSR. बोलते जाओ 3 बार. That's one way of substitution question. Another way is using the corollaries. There are 4 corollaries which I will show you. That's another way. Next, trigonometric integration. So in trigonometry also there are 3 to 4 types of questions, and you have to be very smart to solve questions of trigonometric integrals. Formulas by heart होना चाहिए सबसे पहली बात. क्लास 11th में जो भी तुमने ट्रिग्नोमेट्री के फॉर्मूला पढ़े हैं वो एकदम दिमाग में ताजे होने चाहिए क्वेश्चंस को करने के. And then in the end, particular function. So around 6 to 9 formulas you will get in particular function. 1 by quadratic, 1 by root of quadratic, linear by quadratic, linear by root of quadratic. These are the different types which comes under particular. Then comes your type 2 partial fraction, proper fractions, and under that there are 5 types, 5 forms. Based on that 5 forms, you will dissociate your question and solve. तो बहुत स्टैंडर्ड अप्रोच है. बाय पार्ट्स इज नथिंग बट यूवी रूल ऑफ इंटीग्रेशन. जैसे डेरिवेटिव में यूवी रूल होता है वैसे इंटीग्रेशन में भी यूवी रूल होता है, उसको बाय पार्ट्स बोलते हैं. एंड उसके 2 फॉर्मूला बेस्ड एप्लीकेशन. सब्स्टिट्यूशन इज द मेजर पार्ट. आई टोल्ड यू बाय पार्ट्स पार्शियल फ्रैक्शंस बहुत कम है, सब्स्टिट्यूशन सबसे ज्यादा तंग करेगा आपको. तो चलिए सब्स्टिट्यूशन का पहला चीज हम पढ़ेंगे विच इज integral of f of ax plus b dx is f of ax plus b upon a plus, meaning the coefficient of x should be divided. Let me take an example to explain you. Integral of sin x क्या होगा? माइनस cos है ना, क्योंकि डेरिवेटिव ऑफ cos x माइनस है. तो इंटीग्रल ऑफ sin 3x plus 5 will be what? You don't have to do all together substitution. Let 3x plus 5 be equal to 2. इतना टाइम पास नहीं करने. Simply it will be minus cos 3x plus 5 divided by 3. Like your chain rule, man. In derivative, you used to multiply with this term. You used to multiply with the derivative of this term. Like derivative of sin will be cos, and then you by chain rule multiply with derivative of 3x plus 5. Here you will divide with the derivative of 3. डेरिवेटिव में मल्टीप्लाई करते थे डेरिवेटिव से, यहाँ पे डिवाइड करेंगे. और यू कैन इन अदर वर्ड्स यू कैन से सिंपली डिवाइड विद द कोएफिशिएंट. दैट इज व्हाट आई सेड. ए को डिवाइड करना. दैट्स योर फर्स्ट थिंग. ऑलराइट. नेक्स्ट, so when to use substitution, when to use a substitution in a question. So whenever you will see function and its derivative in the question. Like for example, x square and its derivative is 2x. So if you're seeing x square and you can see x, you may not say 2x, but you are seeing x, 3x, 100x, 1 by x. If you see x square and x, कर सकते हो substitution. If somewhere you see sin x and somewhere you see cos x, sin x, cos x, they are functions and derivatives. Go for substitution. So wherever you see function and its derivative, you should approach substitution. ठीक है. सब्स्टिट्यूट दैट फंक्शन एज टी. साइन एक्स और कॉस एक्स दिख रहा है. साइन एक्स इज द फंक्शन, कॉस एक्स इज द डेरिवेटिव. सब्स्टिट्यूट साइन एक्स एज टी. So how to do that substitution? LDSR, let, differentiate, substitute, resubstitute. That's the 4 step you will follow in each question. I was talking about some corollaries, isn't it? 4 corollaries. This 4 corollaries will also help you solve the question. First one, f of x raised to n into f dash of x is f of x raised to n plus 1 upon n. Second, f dash of x upon f of x very frequently used is log mod of f of x. Matlab, if in the numerator you have derivative and denominator you have function, then the answer will be log mod of function. Can you see? Sin x is the function and its derivative is cos x. Function, derivative. log mod of function, log mod of sine. Cos upon sine is nothing but log of cot, not log, integral of. So this is how you get a formula for integral of cot x, log mod of. ठीक है, second one. Third one, integral f dash of x upon root f of x is 2 times root f of x. Let's see, and last but not the least, this is also important by the way. हमारे पास कुछ बढ़िया वाले स्टार्स हैं, हम उसको यूज करेंगे, ये वाला नहीं यूज करेंगे. और नेक्स्ट है x रेज टू n माइनस 1 इंटू एफ डैश ऑफ x रेज टू n इज f ऑफ x अपॉन n. ठीक है, ये 4 कोरोलरीज का इस्तेमाल. नेक्स्ट, so as I said, integral of cot x, we found out it was log mod of sin x. You all should try to find out integral of tan x, sec x and cosec x also with the in the same manner. Tan x can be sin by cos and you have a minus sign, so it's log mod of cos x. Minus sign will include and give us log mod of sec x. Please by heart this 4 formulas in addition to the 18 formulas list you saw there earlier. Tan x, cot x, sec x, cos x. Next, moving on to integration of trigonometric identities. Whenever you have questions like cos square x, sin square x, cos cube x, sin cube x in the question, always break down the higher power to lower power. If you have integral of cos square x, we don't know the formula for cos. So try to get rid of this 2. 2 को हटाओ और 1 लेके आओ पावर में. Make it linear. How? Cos square x is 1 plus cos 2x by 2. If you have integration of sin square x, you can write it as 1 minus cos 2x by 2. If you have cos cube x, this is nothing but your cos 3 theta formula. Can you realize? देखिए, cos 3 theta was 4 cos cube theta minus 3 cos. Rearrange the terms, that is you keep cos cube on one side, shift everything on the other side. Cos cube x will be equal to cos 3x plus 3 cos x divided by 4. So if you have integral of cos cube x, use this formula, make it linear. Can you see now the powers are linear? You can easily find the integration of cos x, integration of cos 3. Integration of cos x is sin x, integration of cos 3x is sin x, sin 3x divided by 3. है ना, कोएफिशिएंट ऑफ x से डिवाइड करेंगे और 1/4 तो कांस्टेंट है, बाहर आ जाएगा. So that's how we always try to bring higher power to lower power. Now someone will ask me, ma'am, what if we have cos raised to 4x? 2, 3 is fine, ma'am. What if we have 4 cos raised to 4x? Boss, you will use this formula 2 times dx. It is nothing but your cos square x the whole square dx. Multiple ways are there to solve a single question. 1 plus cos 2x by 2 the whole square dx. And now this 2 square 4 comes out. 1 plus cos 2x the whole square, a plus b the whole square is a square plus 2ab plus b square. And now can you see the question has been simplified a lot. You all can solve. Integration of 1 dx. What is integration of 1 dx? X, not 1. So 1, then 2 times integral of cos 2x dx. And then once again you have square. अरे यार फिर से square आ गया. What to do now? We don't know the integral of square. We can always convert it. We can always convert double angle, right? So cos 2x will become 1 plus cos 4x by 2 dx. And now, finish it. Integration of dx. Integration of dx is x. 2 times integration of cos is sin 2x dividing by the coefficient of x which is 2. यहाँ पे separate करो 1/2 and integration of dx is x plus 1/2 integration of cos 4x is sin 4x but divide by the coefficient of x. Do not forget to put plus c in the end. बहुत पाप लगेगा. If you forget plus c, you won't be forgiven. End में just multiply this 4 inside. 2 cancels. Here 2 4s are 8. 8 4s are 32. Multiplying will give you the final answer. Question is solved. So always this is one type of question in okay. Trigonometry में this is type 1 direct. Type 2 when you have higher powers like cos square, sin square, cos square. There is one more way to simplify sin square, by the way. This is type 3 whenever you have product to sum and sum to product. If you have two terms in multiplication, you can convert them into addition, because we haven't yet learned the UV rule by parts, and by parts will make it more difficult. So if there is multiplication between two trigonometric functions, convert it into addition, subtraction and easily take their integration. है ना, यहाँ पे अगर इंटीग्रल है मान लो, तो तुमने इसको कन्वर्ट कर लिया. This taking cos x integral is very easy. Taking sin x integral is very easy. So the question will simplify very much. Type 3. Next is your type 4. When you have 1 upon a sin square x b cos square x, या फिर a plus b cos square x, a plus b sin, or the whole square, something like that. Whenever you have a question of this sort, here are the 3 steps which you will follow. Divide numerator and denominator by cos square. Numerator, denominator, entire. So numerator, if you are dividing with cos square x, you will get 1 upon cos square x. 1 upon cos square x can be written as sec square x. So numerator will now have sec square x. Well, you're dividing denominator also with cos square x. है ना? So this cos square will get cancelled. What about sin upon cos? Tan square x. So change denominators. Sorry यहाँ बच्चों, यहाँ पे मैंने उल्टा लिख दिया. मैं चेक कर देता. Wait. 1 minute. Okay. Tan square x we will have. And now बिल्कुल सही था यार. And change denominators sec square x if any to 1 plus tan square x. If there is any sec square in the denominator by mistake on division, in this question we don't have, but in other types of questions probably you will have. Okay, in this type of question you will get a sec square maybe. So if you have any denominator में sec square x, only denominator sec square x should be changed to 1 plus tan square. Numerator sec square x as it is. And now all you have to do is substitute tan x equal to t. Question will be solved. Tan x equal to t substitute करो. Then LDSR, let differentiate substitute. Question will be simplified very much. Next type of question, this is your type 4 के बाद में आता है type 5. Type 5 under trigonometry, we are talking only about trigonometry so far. If whenever you don't have squares now, a sin x, b cos x, a plus b sin x, a plus b cos x, or this type, always go for half angle formula. Sin x can be replaced as 2 sin x by 2 into cos x by 2, or cos x as 2 cos square x by 2 minus 1. Or you can use the tan formulas of sin and cos. 2 tan upon 1 plus square x by 2, 1 minus sin square x by 2, 1 plus tan. Always these two methods will only solve such a problem. So all you have to do is write down. And whenever you come across a question of any type, then you should know which method to use and which to not. For example, if I take, add कर लेती हूँ 1 upon 1 minus 4 cos square x. Wait. This is a random example. Question आ गया, ठीक है? You have to solve and get the answer. Now, is it type 1 direct formula, or is it type 2 or type 3, type 4? कौन सा type है? Is it type 1 direct formula, type 2 where you have powers 2, 3 or 4? Or is it type 3 where you have sum to product, product to sum? These 4 formulas are written, guys. You also know there are 4 more formulas. This is product to sum. There is sum to product formula. Type 4, is it type 4? Oh yes. Is it type 4? Yes, it is like this. A plus B cos square x. It is like type 4. And if it is type 4, you are able to understand, you will remember the steps and solve the question. What we will divide numerator and denominator by cos square. So this will give us numerator 1 upon cos square x upon 1 upon cos square x minus 4 cos square x upon cos square x. My dear bacha logs, cos square cancel. Numerator cos square x, let it be sec square x. But what did I say? Denominators cos square x. Denominators cos square x, if any, you have to change it into 1 plus tan square x. बोला था या नहीं बोला था? सच बताओ. बोला था या नहीं बोला? Change denominator and sec square x is upon tan square x. 1 minus 4 is minus 3x. My dear bacha log, what was the next step? Divide karo, replace sec square with 1 plus tan square. Next step is you substitute, you let tan x be equal to t. LDSR, differentiate LD. Derivative of tan x is sec square x, dx is equal to dt. Substitute it in the question, in the integral. I will be equal to sec square x dx becomes dt, tan x will become t, and 3 can be written as root 3 the whole square. And now this is a chalu chalta filta formula. Do you know this formula? 1 upon t square minus root 3 square, or 1 upon x square minus a square. पक्का पता है? 1 upon 2a log mod of t minus a or t plus a. So I always tell my students, you have to go by the sign of coefficient. Coefficient or constant. Constant is negative, so negative up. If constant is positive, plus up. Constant is negative, negative up, positive down. Always opposite. So t minus root 3, t plus root 3. And my dear bacha logs, एक step तो रह गया, which is R for resubstitute. R for resubstitute. You will resubstitute to get the 1 upon 2 root 3. t क्या है भाई साहब? tan x. समझे? So identifying the type is also extremely important, guys. Extremely important. If you know the type, it will help you. Like I spoke about this half angle. Next, here is a question. Which type it is? Integral of sine cube dx. Ma'am, it is type 3. है ना? Type 3 था ना वो? नहीं, type 2 था. Type 2 था. Higher part. Number doesn't matter यार. तुमको logic पता होना चाहिए. तो आप बोलोगे मैम sin cube x, let us write it as 3 sin x minus cos 3x by 4. 3 sin x minus cos 3x by 4. cos तो होगा ही नहीं फॉर्मूला में, गलती से ये कैसे आ सकता है? sin 3x. चलो, good. All right, separate 3 by 4 integral of sin x dx. Separating minus 1 by 4 integral of sin 3x dx. 3 by 4 integration of sin is minus cos. Integration of sin 3x will be minus cos 3x. Divide by the coefficient plus c, which is minus 3 by 4 cos x plus cos 3x by 4, 3s are 12 plus c. That's your answer. Well, there is one more way you can approach this question. That is, sin cube x can be written as sin square x into sin. Agreed? Okay. Sin square x can be further written as 1 minus cos square x into. Very good. Now LDSR, let cos x be equal to t. Why LDSR? If you are able to see the function and its derivative, you can do substitute. If you can see sine and cos, or cos and sine, they are derivatives of each other, you can do the substitution. So if I take cos x equal to t, sin x dx will be minus dt. है ना? Let differentiate, substitute in the integral. 1 minus t square into sin x dx is minus of dt. Minus sign taken inside, it will be t square minus 1 dt. Integral of t square is t raised to n plus 1 upon n plus 1. Integration of 1 dt will be t plus c. What is left, my dear bachcha log? Last step, LDSR, LDSR, LDSR. Cos cube x by 3 minus cos x plus c. सही है क्या यार? तो दोनों ने अलग आंसर्स क्यों दे दिए? किस खुशी में? एक बार देख लेते हैं। क्या करें हम? अब हम क्या करें? अलग अलग आंसर्स आ गया, क्या ये गलत है? नहीं बेटा, बिल्कुल सही है यार. जस्ट कन्वर्ट ना. यहाँ पे यू पुट cos 3x is equal to 4 cos cube x minus 3 cos x. Terms will get cancelled. I mean, if you want, you can check quickly. Cos 3x, we can write it as 4 cos cube x minus 3 cos x by 12. And here you have minus 3 by 4 cos x. 4 ones are 4 threes are. Can you see cos cube x by 3? And 3 ones are 3 fours are. Minus 3 minus 1. Minus 4 by 4 cos x, which is minus cos x. So these two are same. They are equivalent forms of each other. And in mathematics, you will be glad to know that equivalent forms will always get full marks. Don't have to match. They should be equivalent. Next is this substitution chart, which I don't know, you have seen it in ITF chapter. You have seen it in continuity differentiability, and see it once again here in integration. You have seen it in application of derivative also. Whenever it's a square minus x square, substitution most likely is sine and cos. X square minus a square, cos and sec, cosec and sec. Plus, if there is a plus, tan and cot. And if there is such kind of a thing, then double angle, right? Tan square, cot square. Remember this, it will help you in solving questions. Now we move on to particular functions. Actually, this formula was used in the previous question. 1 upon x square minus a square. No, this is plus. 1 upon x square plus a square, 1 upon x square minus a square, 1 upon a square minus. Always the confusion is about the formula. So I am giving you a hint. Please remember this hint. Follow the sign of constant. If constant is negative, numerator will be negative, denominator opposite sign. If constant is positive, your a is positive, isn't it? Plus a square. So numerator positive, denominator opposite sign. 1 upon 2a, log mod of xa, minus plus, plus minus. How to decide? Based on constant. And what about the first formula? Guys, this is the formula which we saw in the 18 formula list. Derivative of tan inverse is 1 upon 1 plus x square. The integral of tan inverse will be, integral of 1 upon 1 plus x square will be tan inverse. उल्टा पुल्टा relation है कि नहीं है? तो 1 upon x square plus a square, only difference is 2a की जगह a आएगा. ठीक है? So based on that, you mainly get questions in the form of 1 by quadratic. You get questions of 1 by quadratic form. Where what you have to do in such a question, in this type, whatever is written here, I don't understand. If you are able to understand, good. It's there in your textbook. Not interested. Whenever you have a question of 1 by quadratic, denominator is a quadratic. What we do is, first step, have I written the steps? First step, we will make coefficient of x square equal to 1. Make coefficient of x square equal, always. Right? Here the coefficient of x square is a. You will make it 1. How? Take a common na. A common le le bhai sahab. Second, add and subtract third term. Add and subtract third term. What is this third term? Third term, do you all know? Half into coefficient of x the whole square. 10th standard में delete कर दिया था क्या COVID batch में? In order to make it a perfect square, half into coefficient of x the whole square, we add and subtract. Make it a perfect square. Make it complete square or perfect square, whatever you like to call. Make it complete perfect square. And fourth step, use special integral formula. Use particular function formula. This is particular function. To use any of this formula. Using this formula will solve a question. These 4 steps are going to solve your question. Do you want to check in the next question that I have? Let's apply these 4 steps here. Integral dx upon 5 minus 8x minus x square. नाम नहीं दिया था, हमने दे दिया. What was my first step? Coefficient of x square should be 1. Is the coefficient of x square 1? Make it 1. How to make it 1? By taking minus common. So if I take minus common, we will have okay, minus 5 plus 8x plus x square. क्या बात है, क्या बात है ना? And then what was my next step? अपना next फंदा क्या था? Add and subtract the third term. What will be the third term? It is half into coefficient of x the whole square. 4 square 16. So we are going to add and subtract 16 in this. Added 16, subtracted 16. Minus 5 was already there. So can you see add 16, subtract 16. The first 3 terms will make a perfect square. Make a perfect square. A square plus 2ab plus b square is a plus b the whole square. And minus 16 minus 5 minus 21 can be written as minus root of 21 the whole square. Root 21 the whole square and minus. Isn't it a formula of particular function 1 upon x square minus a square? And according to that formula, answer will be minus sign, let it be. The formula says 1 upon 2 times a, 1 upon 2 times constant, log mod of x plus 4, 21. X plus 4, 21. Now plus and minus I always get confused. So I follow the constant sign. The constant is negative, so numerator negative, denominator positive. Guys, the question is solved. The question is solved. Can you see? That's how we follow the 4 steps in a question. First step, this minus sign was taken common. Second step, added and subtracted. Third term, perfect square. Fourth term, use a formula. Done. Moving on. These 3 are also a part of particular function. Only difference is now you have roots. So because you have roots, there is no denominator firstly. None of them has a denominator like the previous one. And everywhere there is plus sign. So no point of confusion. Ma'am plus डाले minus डाले कुछ नहीं बेटा plus ही है. Right. What was derivative of sine inverse 1 upon root 1 minus x square? So what will be integral of 1 upon root 1 minus x square? Sine inverse. Instead of 1 there is a, so divide by a. The others in both of them, all you have to do is variable plus question. This x is the variable, a square is the constant. A is the constant, x is the variable. Log of variable plus question. This is my question copied. Log of variable plus question copied. So based on this, you get a question of another type, which is 1 upon root of quadratic. 1 upon root of quadratic. Very similar to the previous one. You will follow the exact 4 steps. You will follow the exact 4 steps. Coefficient of x square you have to make 1. Add and subtract third term. Make it a perfect square. Use a formula. Same 4 steps. Same 4 steps. Like 1 by quadratic. ठीक है, वो वाले के जैसा सेम. फिर अगला टाइप आता है लीनियर बाय क्वाड्रेटिक, लीनियर बाय रूट ऑफ क्वाड्रेटिक. This is another type of question which you have in particular. Linear by quadratic or linear upon root of quadratic. And how to solve this question? What are the steps in? Always, it's written there already. First step, what we will do is we will take linear is equal to a into derivative of quadratic plus b. ठीक है? You will solve and find a, b. Find value of a and b. You will solve this equation, equate both the sides, solve and find value of a and b. Next step, substitute A and B in equation 1. ठीक, इसको थोड़ा अलग दिखाते पता चल in. Next, substitute 1 in integral in I. In the integral you will put it back. Once you put it back in the integral, you will always find two parts of that integral. You will always find two parts. One of the parts will be always having a corollary. One of the parts will always be a corollary and the other part will be a type. Now, which corollary it will be? One of the parts will be either f dash of x upon f of x or f dash of x upon root f of x. The first part will always form any of these two corollaries. And the second type, what I was talking, either it will be 1 by quadratic type or it will be 1 upon root of quadratic. You all know how to solve this. F dash of x upon f of x is log mod of f of x. This is also corollary to root of f of x. How to solve this? 4 steps. How to solve this? 4 steps. So once you do 4 steps, in the 5th step, you will again get two forms where you have to proceed with 4 steps. Plus 4 formula. ठीक है, तो ये क्वेश्चन ऐसे हमेशा सॉल्व हो जाएगा. एग्जाम्पल चाहिए क्या तुम लोग को? चलो, ये इसमें मैं I'll do this 5 steps which I've written here. 5 steps, and after 5 steps you will see that it is forming two types, corollary and one of the type, either one of the type. All right, here is a question, linear by quadratic. The step says, step 1, let us say linear is equal to, what was it? A into derivative of quadratic plus b. What is x square derivative? 2x plus 4 plus. This is my equation. Solve, let's solve it. Solve it and get the value of a and b. 2ax plus 4a plus b. Equate the LHS and RHS. 5 is equal to 2a, a is equal to 5 by 2. And 3 is equal to 4a plus b. b will be equal to 3 minus 4 into 5 by 2. 2 ones are 2 twos. b is equal to 2 5s are 10 minus, check kar lo yaar, a and b. Once you get a and b, you will substitute it in 1. 5x plus 3 is equal to 5 by 2 times 2x plus 4 minus 7. So step 1, step 2 was solve, step 3 was putting it back in 1, and step 4 was putting it in the integral, putting it back to I. This is your I. So in place of 5x plus 3, you will have 5 by 2 times 2x plus 4 minus 7. Denominator is same. Dx. Step number 5, you will see two types. Now wait. Are you able to see? First type, 5 by 2 times integral 2x plus 4 upon root of x square plus 4x plus 10 dx minus 7 times integral root of square plus 4x plus 10. My God, can you see? After step 4, it's there into two parts. First part is your corollary, f dash of x upon root f of x. Second one is 1 upon root of quadratic. We have got this and this, type 2 के हिसाब से. Using a formula, guys, 5 by 2 is a constant. F dash of x upon f of x is 2 root f of x, 2 times root of x square plus 4x plus 10 minus 7 integral. Let's make it a perfect square. First step, coefficient of x square should be 1. It's already 1. Lucky you. Add and subtract the third term. Half into coefficient, it will be 4. So 4 plus 6. These three terms will form a nice perfect square. 2 cancel. 5 times root of x square plus 4x plus 10 minus 7 times integral dx upon a plus b the whole square minus root 6 the whole. 5 times root of x square plus 4x plus 10. Patience. 1 upon x square, 1 upon root x square minus a square formula. 1 upon root x square minus a square is log mod of x plus the whole question. Do you remember I was saying variable plus question? How is the formula? Variable plus question. This question copied. So that's what I've done. Variable is x plus 2 and whole thing is question copied. That is your answer for the given integral. The question is solved, done and dusted. Very nice, very nice. Let's move to the type 2 finally, guys. Type 2, which is integration by partial fractions. We did substitution, we did trigonometric integrals, we did particular functions. Now we are doing partial fractions. So mainly partial fraction decomposition will be used whenever you have a proper rational fraction. Proper rational fraction is when the degree of denominator is greater than the degree of numerator. Improper means ulta. So in case of proper fractions, they will be decomposed like this. There are 5 types. I have written the name of all. 1, 2, 3, 4, 5. First type is when you have non-repeated linear factors. See, the linear factors are non-repeated. So you simply decompose a upon first factor, b upon second factor. Type 2 repeated linear factors. Now the factor is repeating 2 times, x minus a into x minus a. So decompose as a upon x minus a, b upon x minus a the whole square. You are repeating the same thing. Third type is non-repeated linear factors. That means same thing but 3 times. So a, b, c. Fourth, similar to second. Second and fourth are similar. First and third are similar. So second and fourth. Fourth is again repeated linear factor. X minus a is repeated twice. So you will also write it twice. A upon x minus a, b upon x minus a, c upon x. And last but not the least, whenever you have quadratic in the denominator, and remember the quadratic is not further factorizable. You are unable to factorize it further. Okay. In that case, a upon whatever factor. And if the factor is not linear, all the other options were linear. Now the factor is not linear. So numerator will also be bx plus. Factor is quadratic, numerator linear. Factor linear, numerator constant. Numerator is always 1 degree less. So degree 2, degree 2. That's your partial fraction. Moving on to integration by parts, my dear bacha log. Fifth I the fifth. What is it? Fifth I the fifth. Fifth, F stands for first term, S stands for second term, right? I stands for integral. In order to remember this formula, just say 5 times. Fifth I the fifth. Fifth I the fifth. Fifth I the fifth. First term integral, second term minus integral derivative of first term integral second term. That's how I remember. First term integral second term minus integral derivative of first term, this is u, into integral of second. First term integral second term minus integral derivative of first term integration of second term. Okay. Now how to decide this first and second term? For that we always use the late rule. Late rule. I late. I am always late. I am never late, guys. You will not see a teacher more punctual than me. No, it's a fact. I'm not kidding. Yeah, I late. So you can say I late. I never liked I late. You can say I late. I for inverse functions. They are like the priorities in your chemistry carboxyl group. वैसे ही priority दिया है. Inverse has the highest priority. Then logarithmic, algebraic, trigonometric, exponential. I late, elate. With this priority, you will decide what should be the first term, what should be the second term. Wherever you find, let's say, 2 trigonometric functions coming together or 2 algebraic functions together, then how will you decide the priority? You will always choose the first function which is easily differentiable and second function which is easily integrable. Okay? What did we learn first? We learned first differentiation and then integration. So first function easily differentiable. Connect. पहले हमने डिफरेंशिएशन पढ़ा तो पहला फंक्शन डिफरेंशिएट इजीली होना चाहिए. फिर हमने इंटीग्रेशन पढ़ा, so second function should be easily differentiable. Now let's say there is no second term. If there is a single function, you can put 1 as the second function. These are some of the hints to solve questions of biparts. Application of biparts has these two formulas. Integral e raised to x f of x plus f dash of x. E f of x के साथ भाग जाएगा, है ना. E ने पतली गली लेकर निकल गया f of x. So you have f of x also, f dash of x also. E will run away with f of x. That's one formula. Second, little different, you won't see it in your textbook, JEE wala hai, x into f dash of x plus f of x. Now here x is already with derivative, x already derivative ke sath bhaga hua hai. So after the integration, x will go with f of x. Initially it was with derivative, after integration it will go with function. Derivative को छोड़ दिया. एक क्वेश्चन करते हैं, खत्म करते हैं. बहुत जल्दी हो रहा है, आपको लग रहा है मैम और प्रैक्टिस करना है, क्या करें बेटा. e raised to x दिख रहा है मुझे, 2x कुछ दिख रहा है. So I'm going to do LDSR. Let 2x be equal to t. Differentiate. Derivative of 2x, 2 is equal to dx by dt. Or in other words, dt by dx. Bad. Or in other words, dx is equal to dt by. ठीक है. Let us all substitute whatever we did in the integral I. So 2x can be written as t minus 5 upon t minus 3 the whole cube, and e raised to t dx can be written as dt by 2. Putting the constants aside and trying to simplify it further. 1 by 2 out, t minus 3 minus 2 upon t minus 3 the whole cube into e raised to t dt. Separate t minus 3 upon t minus 3 the whole cube minus 2 upon t minus 3 the whole. जादू, कोई जादू नहीं है, सारा मैथमेटिक्स है. 1 upon t minus 3 the whole plus minus 2 upon t minus the whole e raised to t dt. My dear बच्चा लोग, can you all see function and its derivative? Can you all see e raised to x, f of x plus f dash of x? Whenever you have e raised to x outside and inside, there is both f of x, f dash of x. E raised to x will run with whom? Function or its derivative? E raised to x will run with function. Please check carefully. Here, your f of x function is 1 upon t minus 3 the whole square. What is derivative of 1 upon t minus 3 the whole square? This will go in the power. Derivative of x raised to minus 2 is minus 2 times x raised to minus 3. So minus 2 upon t minus 3. The f of x, f dash of x, e raised to x. The answer will be I is equal to e raised to t into, it will run away with the function 1 upon t minus 3 the whole square, and there was 1 by 2 already outside the integration. The question is solved, but LDSR complete नहीं है, तो एक बार रीसब्स्टिट्यूट करके इसको खत्म ही कर देते हैं. क्या कहते हो भाई साहब? I is equal to e raised to 2x upon 2 into 1 upon 2x minus 3 the whole square. Do not forget plus c, बहुत पापे लगेंगी. Okay, bachalogs, LDSR. So this was a question on application of biparts. Here is a last type 2.5, some more type of integrals जो कि mainly ना definite integration में use होगा. You will start the second question with this formula. Root of x square minus a square, x square plus a square, and a square minus x square. So all the previous formula was 1 by quadratic, 1 by root of quadratic. Here it is quadratic but in the numerator. The previous one were in the denominator. It's combination of two parts. Matlab, by the way, which sign should come here? Plus, minus. How to decide? Always go with the sign of constant. Constant, negative. constant, positive, positive, constant, positive, positive. So in between, the sign is decided by constant. Can you recollect this formula? This is your 1 upon root quadratic, 1 upon root quadratic, 1 upon root quadratic. So the second part is nothing but a formula from 1 by root quadratic, log mod of variable plus question, log mod of variable plus question, variable plus ये question copy, ये question जो है वो copied, ये question copied, ये question copy नहीं है क्योंकि वहां पे अलग है, वहां पे formula है sin inverse of x by, right? Okay. So second part is 1 by quadratic. First part, all of them, first part is same guys. X by 2 question. X by 2 question copied. X by 2 question copied. The first part is always x by 2. Then you copy down the question. Then plus or minus divide. You will decide on the basis of constant. And second part, a square by 2. Every one of them has a square by 2. All of them has a square by 2. And second part is 1 by quadratic वाला formula. जो भी वहां पे 1 upon root of quadratic वाला formula था वो सेम यहाँ पे अप्लाई करना है. ठीक है, root of quadratic formula is x by 2 times. You will copy the question, that is you will copy root of quadratic plus minus a square by 2 वहां से quadratic वाला form. That's how the complete chapter is over. Hope you will prepare, study well, and put lots of hearts in the comments and keep sharing, keep smiling. That was all from my side for this chapter. Stay tuned for the next important chapter, definite integration. All the very best, bachcho. Keep smiling. Take care. Bye bye. Love you all.